This is video 13 for College Algebra, and we're going to be talking about inverse functions today. First of all, the inverse of f of x is written like this, f to the negative first power of x, but we read it as, we just say f inverse. All right, and so a couple things about the function and the inverse is the domain of the regular function, just our f function, becomes the range of the inverse. And the range of the function becomes the domain of the inverse. So those just actually flip-flop. Another part about inverses are the graphs of f of x and f inverse of x are actually a reflection over the line y equals x. And so you can pull up Desmos or your graphing calculator and see how that's a reflection over that line. And so what that means is if I have a point just x, y, when I find the inverse, my point will be y, x. And then to verify that two functions are actually inverses, you'll just need to compose it, and then it should equal x. All right, so here we are going to verify that the f of x and h of x are actually inverses. And so in that, we are going to compose and plug in our h function into our f function. And so what this looks like is I'm going to take my x function, or my f function, and sometimes it might be helpful to write it out like this before we actually do our composition. Okay, so we're plugging in f divided by 5 plus 2 into my f function. And so what that looks like is this. Okay, and so then we can simplify. Our plus and our minus 2 are actually going to cancel out. So we'd have 5 over x. Well, remember when we have a fraction inside of a fraction, we can multiply by the reciprocal. So this would become 5 times x over 5, which does equal x. So here, yes, they are inverses. All right, another way to tell if something has an inverse or is an inverse is the horizontal line test. We've talked a lot about the vertical line test in algebra, but here we're talking about the horizontal line test. So f has an inverse if and only if no horizontal line intersects the graph at more than one point at one time. Okay, and we'll do an example of that here in a second. It's also one-to-one. That's when each dependent variable corresponds to exactly one independent variable. So a function has an inverse if it is one-to-one. So we take a look at our first graph. If I can draw a line anywhere here through this and I pass one point at one time, so that does have an inverse. However, on this quadratic, I can't. This does not have a inverse because it crosses that function at two different spots, so it does not have an inverse. Okay, looking at our table, -2 goes to 4 and 2 also goes to 4. That would kind of be the same, that's the same as our horizontal line test. Like we can see if we were to graph this, that this would not be would not pass our horizontal line test, or this means it's not one-to-one. So this is a no. No function, no inverse. The only one that has an inverse is that first graph. All right, so now how to find an inverse. First of all, we're going to use the horizontal line test and one-to-one to see if it even has an inverse at all. We don't want to waste our time if it's not necessary. All right, so we can graph this. We can see that this does pass the horizontal line test. This is just a rational function. And so then we're going to move into our steps. So first of all, change f of x to y. So we have y equals our function. And then we flip our x and y and solve for y. So this now becomes x equals 5 minus y over 3y plus 2. Now when we solve this, we can cross multiply. We've got those two fractions equaling each other because remember we can just say x over 1. And so then we would have x times 3y plus 2 equaling 5 minus y. And then we can distribute. And then we can put everything that has a y on one side and everything that has an x on the other. And our goal here is so that I can take out a GCF of y. So from here I can now take out that GCF of y. And now I can divide by 3x plus 1. All right, and then our very last part of this is to change y to f inverse. All right, and so that is my new function. And again, you'll have to find your domain restrictions. So for this, we would have to say, well, x can't equal negative 1/3. That's because that would make our denominator equal to 0. And then you also have to look back at your original function too, what our domain can't equal. So it also can't equal negative 2/3. All right, and that's how to find an inverse. Now, if you wanted to check your problem, you can do the composition of the two functions and you should equal x. All right, and so that is just some more information on inverse functions.